MS Ramaya University of Applied Sciences.
Hi students, let us discuss the experiment to construct SR latch using NOR gates. Aim of the experiment is to construct and verify the functionality of SR latch using NOR gates. A latch is similar in functionality to a flip-flop. Flip-flops and latches are a fundamental building block of digital electronic systems used in computers, communications, and many other types of systems. Flip-flops and latches are used as data storage elements. The logic diagram of SR latch is as shown in the diagram. The truth table of SR latch is as shown in figure. The apparatus required for this experiment are trainer kit, connecting probes, IC 7402. Procedure for verification of latch. Connect the trainer kit to AC power supply. Construct an RS latch by connecting two NOR gates as per logic diagram. Connect logic sources to RS inputs and outputs QQ' to logic indicators. Apply various RS combinations and observe QQ' outputs. Verify the truth table. Switch off the AC power supply. Conclusion. The functionality of SR latch is verified by obtaining its truth table experimentally.
Hi students, name of the experiment is construct SR latch using NOR gates. Aim is to construct and verify the functions of SR latch using NOR gates, and the apparatus required for this experiment is digital IC trainer kit. So this is the digital IC trainer kit which we are using to perform the experiment. Now it consists of various knobs. At the top you can see there are red color knobs which indicates the outputs. The outputs can be seen through the LEDs which are there at the top of the red color knobs, and at the bottom you can see there are black color knobs. These are used for the connecting the inputs, and also you have input controllers, that is the toggle switch. There are 10 input switches and there are 10 controllers. These are the toggle switches, and you have 4 IC bases here to place an IC into each base. So now each IC base consists of one IC slots, one IC base. This IC base consists of 16 slots. So there are 8 slots at the left and remaining 8 slots at the right, and each IC base consists of different pins. The input pins, we can say these are the input pins. Each pin represents each slot, and also each base consists of VCC and ground pin in order to give a power supply to the IC which we are going to connect here. And these are the knobs which are there to check the conductivity of the patch cords. This is 7402 IC which represents the NOR gate. This we are going to construct the SR latch in this experiment, and patch cords. So these are the patch cords which we are using to connect the circuit on the digital IC trainer kit. Now let us start the connecting of the circuit based on the circuit diagram. Now we will place the IC into the IC base. So this is the 7402 IC which represents NOR gate, and make sure while placing the IC into the IC base, the notch of the IC should be always upward direction. So now I am placing it. So place it firmly and close the lever. Make sure the IC is not coming out. So now before connecting this patch cords into the circuit, let us check the conductivity of each patch cord by connecting it to the conductivity tester. So if beep sound comes, so power supply is off, I will turn on. So now if beep sound comes, that means this patch cord is working properly. Similarly, you have to do patch cord checking for all the patch cords available with you. So beep means it is working. Now let us do the connections using patch cords. Now according to the circuit diagram, pin number 2 and pin number 6 are the inputs. Before connecting the inputs, let us give the power supply to the IC by connecting pins VCC and ground. Now we will do the connections for the input. Pin number 2 is one input. This represents S input. I am connecting here to the input knob, and also pin number 6 is the another input, that is R. So this is S, this is R. Inputs are connected, and pin number 1 and 4 represents the output of NOR gates. Pin number 1 is output and it is Q bar. I am connecting here, and pin number 4 is another output. I am connecting it here. This is Q. Now this is Q bar and this is Q. Then the output pin number 1, this output is shorted and it is given as a input 5. Similarly, another output pin number 4, this is shorted and connected to the input 3. So now this completes the connections. Now let us turn on the power supply to the digital IC trainer kit. Now that you can see here, it is turned on. Now we will check the outputs according to the truth table. So now these are the inputs. SR, the first input represents S and this represents R, that is set and reset, and the outputs, this is Q bar and this is Q. Now whenever the inputs are 0 0, both set and reset are 0, the outputs will be in a storage state. That means Q is in a 1 position and Q bar is in a 0 position. Now I will try to change the input positions according to the truth table. I will make 0 1. So reset is 1, so therefore the output Q bar is 1 and Q is 0. So this represents reset condition. Then for the another input 1 0, you can see Q is set to 1, Q bar is set to 0. This is nothing but set state. And at the last output, both the inputs are high, that means both set and reset are high. So therefore you can see the outputs both are low. This represents intermediate state of the output. So this completes the experiment.
At MSR UAS, we spark your imagination unlike any other.